Welcome to Two Projects. In this video, we are going to explain the project, a novel decentralized product verification using blockchain technology. Introduction. In this project, a mobile application has been developed to address the complexity of global supply chains and the need for product authenticity. The application provides a reliable solution for businesses and consumers to verify product authenticity and quality, utilizing advanced technologies to offer a transparent and secure approach to product verification. Traditional supply chain management methods face inherent challenges in ensuring product authenticity and quality. Issues such as lack of transparency, difficulties in tracking a product's journey, and the prevalence of counterfeiting and fraud contribute to a breakdown in trust within the supply chain. These drawbacks underscore the critical need for innovative solutions to enhance the integrity of product verification processes. So, to overcome the limitations of traditional methods, the mobile application integrates QR codes and Ethereum blockchain. Blockchain is like a digital ledger that records transactions securely and transparently. In our case, it is used to store information regarding product origins, verification processes, and authenticity checks. Instead of having all the data in one place, blockchain stores records as blocks of data, each with a unique code called a hash. These blocks are distributed across multiple computers or nodes, making it much harder for anyone to tamper with the data or compromise the entire system. And blockchain offers several advantages. First, it is decentralized, meaning the data isn't stored in one vulnerable location. Second, it enhances security because the data is stored in encrypted format that is very difficult to alter or hack. Third, it promotes transparency as all transactions are recorded and visible to authorized users. Fourth, it ensures data immutability, meaning once something is recorded in the blockchain, it can't be easily changed. Finally, it is resilient to failures because even if some nodes go down, others continue to maintain the data. And this initiative capitalizes on Ethereum's blockchain, renowned for its smart contract capabilities. These contracts on the Ethereum network not only secure but also meticulously track critical product details, further elevating transparency and reliability in the supply chain. Objective of the project. So, as I mentioned earlier, the primary objective is to develop a system that fundamentally transforms how product verification occurs in supply chains. By decentralizing the verification process, the project aims to reduce dependence on centralized entities. This shift promotes enhanced trust and authenticity throughout the supply chain, ensuring that product information is reliable and less susceptible to manipulation or fraud. And the project seeks to leverage blockchain technology to create a distributed and tamper resistant ledger. By doing so, it introduces a transparent and secure system for recording and monitoring product details and movement in real time within the supply chain. This utilization of blockchain enhances accountability and reduces the risk of data manipulation, providing stakeholders with accurate and trustworthy information. And the incorporation of smart contracts using Solidity on the Ethereum blockchain is a key aspect of the project. Smart contracts are programmable agreements that execute when predefined conditions are met. In the context of product verification, these contracts enhance the reliability of the process by ensuring the secure and accurate recording and validation of critical product details. This integration contributes to the efficiency and integrity of the verification process. Requirements needed to execute this project are software requirements. Python ideally of 3.7.0 version, Node.js, Visual Studio Community version, Ganache, and MetaMask Chrome extension. Backend languages used are Python, JavaScript, and Solidity. Framework used is Flask, and front-end languages used are HTML, CSS, JS, and Bootstrap 4. Hardware requirements needed are processor of i5 and above, RAM of 8 GB and above, and ROM of 20 GB and above. To execute this project, we have designed few modules. So first we'll understand the manufacturer modules. The first one is manufacturer login. Here manufacturers access their account securely through authentication, gaining entry to a personalized dashboard. This login serves as a gateway for manufacturers to interact with the system's functionalities. The second module is add product details. In this module, manufacturers input comprehensive product information and upload it to the system. The system then generates unique QR codes for each product, linking them to the provided details, facilitating a secure and traceable product identification process. The third module is View Product Details. Here, manufacturers can review and verify the details of the products they have added to the system. This module enables them to ensure the accuracy of information and make any necessary updates to maintain data integrity. The next module is View Users. This module provides manufacturers with insights into user interactions with their products. It includes a user management system allowing manufacturers to monitor and analyze user engagement related to product authentication and information retrieval. Now we'll see the user modules. The first one is user registration. So users undergo a secure registration process providing necessary information to create an account. This step ensures a verified and authenticated user base within the system. The second module is user login. In this module, authenticated users gain secure access to the system through login credentials. Upon successful login, users are directed to a personalized dashboard where they can engage with various features tailored to their needs. The next module is retrieve product data. Here, users can easily search for and retrieve detailed information about a specific product by entering its unique identifier, that is product ID. This module enables users to access a comprehensive view of a product's attributes and its journey through the supply chain. And the last module is Authenticate Scan. This module allows users to scan the QR code associated with a product, triggering a real time verification process. Leveraging Ethereum's blockchain and smart contracts, users receive instant confirmation of the product's authenticity, enhancing trust and transparency in the supply chain. Blockchain integration. So, blockchain ensures unalterable storage of product data, guaranteeing accuracy and reliability. This feature is crucial for maintaining an undisputable record of manufacturing and distribution details throughout a product's life cycle. Blockchain enables secure product verification by allowing stakeholders to trace a product's history on the tamper resistant blockchain ledger. This transparent trial enhances trust and confidence in confirming the authenticity of the product. Blockchain's decentralized structure minimizes the risk of manipulation or fraud by distributing data across a network. This enhances system security and eliminates vulnerabilities associated with a centralized system, ensuring a robust and resilient supply chain. And smart contracts autonomously executed on the blockchain execute predefined processes such as updating product status and triggering verifications. This enhances process efficiency, reduces reliance on intermediaries, and instills trust in the accuracy of product identification and tracking. And blockchain's transparency and consensus mechanisms foster trust among participants. All stakeholders share the same data, and changes occur through a consensus process, crucial for combating counterfeit products and improving overall supply chain transparency. And we have used Ganache in this project. So, Ganache is a user friendly interface for monitoring Ethereum blockchain activities. It simplifies tracking of accounts, transactions, and smart contracts, making it accessible even for users without in depth blockchain expertise. Ganache offers detailed transaction information, including sender, receiver, amounts, gas usage, and success status, aiding debugging and ensuring transaction accuracy. It also tracks smart contract deployments, confirming correct deployment and functionality. This transparency simplifies monitoring and verification processes. And Ganache lets us dive into the details of each block on the Ethereum blockchain. We can find out when a particular block was added, what transactions took place within it, and how much computing power, that is gas, was used. Ganache also enables data retrieval from stored blocks, allowing developers to access and analyze specific block information. And we have also used MetaMask in this project. So, MetaMask is both an Ethereum wallet and a browser extension. It simplifies cryptocurrency management and provides direct access to dApps, making interactions with blockchain applications easier. And in this project, MetaMask ensures secure Ethereum transactions, promoting transparency by showing the deduction of ETH as fees. The transparency maintains accuracy and ensures confident, reliable financial interactions within the system. Execution of the project. To execute the project, first we need to open the code folder which contains the project source code files. So this is contracts folder in which I have Solidity files. They handle data structures, functions and events with modifiers for validation. This is static folder. This consists of files related to CSS, JavaScript and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML pages. And the project offers two ways to authenticate products. Users can either upload downloaded barcodes directly to the application or use the webcam to show the barcode for quick verification. So this is the run.bat file to start product verification application. And this is run webcam.bat file to start webcam. So first we need to host the server. For that, open the Ganache. So we can see the server has been hosted. Now we'll get back to the code folder. So these are Python main code files. So now double click on run.bat file to start the product verification application. So the Flask framework will host the application locally at the default address, local host and port unless configured differently. This is the local host and this is the port. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. Now click on the action button. So here we can see manufacturer login, user login and new user sign up links. So first we log in as manufacturer. Click on manufacturer login link. So here we have to provide the credentials, username and password of manufacturer. And click on login. So we have logged in as manufacturer. Click on the action button. So here we can see add product details, view users and logout links. Click on add product details link. So here manufacturer can add new product details to the system. Fill in all these details. Product ID would be 1. Product name would be bread. Manufacturer name is Amul. We have to give the manufacturing date. Click on the calendar symbol. So I'm giving it as 1st December 2023. Product expiry date. Click on the calendar symbol. So I'm giving it as 2024 December 1st. Product price would be 100 and we have to give the manufacturing location, that is Hyderabad. Now click on add product button. So we can see the product details are being added to the system. So all these product details will be stored in blockchain in a form of block. We can see that in Ganache. So we can see a block has been created in which all these product details will be stored. So we can retrieve the data from here. Minimize this and we can see the system has generated a QR code to which the provided product details are assigned. This QR code will be used for product verification. So we can download the image by clicking on this link. So I'm clicking on it. So we can see the barcode image has been downloaded. Now click on the action link. Click on logout. Click on the action link. So if we are new users, we have to register first. Click on new user sign up link. Fill in all these details and click on submit button to register. So username would be Ram. Give the password. Give the contact number. Give the email ID. and the address. Now click on submit button. So valid phone number must be entered. Okay, so here we can see user sign up task completed. So all these user details will be stored in blockchain. We can see that in Ganache. So we can see a block has been created in which all these user details will be stored. Minimize this and in MetaMask, click on the extension. We have to give the password here. So we can see I have a balance of 99.9845 ETH in my MetaMask wallet, which represents the deducted amount after recent transactions. In the context of a blockchain, transactions refer to the actions or operations that are recorded on the blockchain ledger. So now click on the action link, click on user login, we'll log in as Ram, give the credentials, username and password of Ram and click on login. So we have logged in as Ram. Click on the action link. So here we can see retrieve product data, authenticate, scan and logout links. Click on retrieve product data link. So here by giving the product ID, we can retrieve the product data. So product ID is 1. Now click on submit button. So here we can see the product details associated with product ID 1. Now click on the action link. Click on authenticate scan link. So here we have to upload the downloaded barcode image. If authenticated, we will get the product details, else we will not get the product details. So click on choose file button. So I'm uploading the image and click on submit button. So we can see the barcode verification is successful and we can see the product details are retrieved. Click on the action link. Click on authenticate scan link. We'll try giving different barcode image. Click on choose file button. So this time I'm giving this image and click on open. Click on submit. So here we can see uploaded product barcode authentication failed. Only if the barcode authentication is successful, we will get the product details here. Now click on the action link and click on logout. Now we log in as manufacturer. Click on the action link, click on manufacturer login link. Give the credentials, username and password of manufacturer. And click on login. So we have logged in as manufacturer. Click on the action button. So here we can see view product details link, click on it. So here manufacturer can view list of products added to the system. Click on the action link again. Click on view users. So here manufacturer can view the details of the registered users. So we can see the username, password, phone number, email ID and the address. Now click on the action symbol and click on logout. So all the transaction details and registration details will be stored in the blockchain as blocks and can be retrieved from there. So if we see in Ganache, so we can see blocks are created. Click on any block. So here we can see the block hash and transaction hash. Click on transaction hash. So here we can see sender address, to contract address, gas used, gas price, gas limit and the transaction data. Now minimize this. Open the MetaMask extension. So we can see ETH balance remains unchanged after each block creation because the project's action don't involve significant ETH transfers. This is normal as not all operations lead to substantial balance changes. So as I mentioned earlier, we can also perform the product verification using webcam. Go to the code folder. Now double click on run webcam.bat file. Instead of executing the project through command line interface, we have created these Windows bat files. So now click on start webcam button. So here we have to show the downloaded QR code image and click on start webcam button. So here we can see the product details associated with QR code are retrieved. We can see the product ID, product name, manufacturer name, manufacturing date, product expiry date, product price, and manufacturing location. So these details have been retrieved from blockchain. So in this way, we can perform the product verification. So the conclusion here is the project marks a groundbreaking shift in supply chain management, introducing innovative technologies to enhance product verification, transparency, and reliability. By embracing decentralization, the project reduces reliance on centralized entities, fostering trust and authenticity throughout the supply chain, from manufacturing to distribution. Blockchain integration ensures the security and integrity of product data, offering a tamper resistant ledger that significantly reduces the risks associated with fraud and manipulation. The incorporation of smart contracts improves efficiency in product identification and tracking. It enhances trust in the verification processes. The transparency facilitated by blockchain and consensus mechanisms establishes trust among participants. This trust, essential for combating counterfeit products, extends to all stakeholders, improving overall supply chain transparency and integrity. The project stands as evidence of the potential of advanced technologies in revolutionizing and securing global supply chains.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.